we're going to go over working with exponents. So let's review. If we have a number that is being raised to a power, then this is our base and this is our exponent, or otherwise known as the power. So 3 to the power 2, or 3 has the exponent of 2. Okay. Now, if we are multiplying two numbers, same base but different exponents, so let's say we are taking, we had 3, so 3 squared, and we are going to multiply it by 3 to the 5th power. If we break this down and just look at what we have here, then we have 3 times 3, that's this part, times 3 times 3 times 3 times 3 times 3. So we could write this all out as 1, 2, 3, 4, 5, 6, 7. So this is 3 to the 7th. Well, rather than having to expand each number as many exponents as it's telling you to, so if this is 3 squared, having to do this, we can just utilize this property of the exponents.
Is this over maybe? Or not yet?
Yeah, let me do it after we get this one,
Okay.
and yeah, we'll slide that. Then we could just say, well, this is going to be 3, that base, and then we could just 2 plus 5, which is 3 to the 7th power. Okay? And that only works if they have the same base. So
I kind of want to interrupt right now. I kind of want to come in and say, because he wrote down some laws of exponents, and I think that the example he just did was this first one right here. So we're saying that these two are 8, or they're the same
Right.
number, right? The same
Right.
base, just different exponents, m and n, so they're different. And then, so you can keep the same base, and then you just add the two different exponents.
right.
The base is the same, but the exponents are different.
And you came up with an example over there that I had never thought of that could be confusing. Let me get this out of the way. So let's say we have 3 squared. If we're multiplying this to 2 to the 3rd, just because we've taken this power and it looks like we've just, we flipped it here and made this base an exponent, because we're dealing with all the same numbers, this doesn't mean that we can utilize our law of exponents. It doesn't work that way. They have to be the same base. They have to both be, in this case, very abstract, both A's. And since they're the same letter, it represents the same
Number.
Which actually brings us back. The exponents, m and n, different letters, different numbers.
Yeah. So in this one, what would it be? I mean, how would you solve that then?
With this one, we would just have to work out the exponents. 3 squared is 9. We're multiplying this to 8, and it's 72. All right, so now, the other, and then I'm only going to give 3 laws. There are other laws. Okay, well, we've done a multiplication problem. What about a division problem? So, if we have 3 to the 5th power, and I'm dividing this by, 3 to the 7th. No, hold on, we'll get to that one in a moment. 3 squared. Again, let's just expand these, look at them, break them. 3 times 3 times 3 times 3 times 3, this would be 3 to the 5th, over 3 times 3, 3 squared. Well, 3 divided by 3 is 1, 3 divided by 3 is 1, and we're left with just 3 cubed, or 3 times 3 is 9, 9 times 3 is 27. Okay. Rather than having to write out this whole piece, we can just say 3 to the 5th minus 2. We can take the numerator, that's going to be the numerator and its base and exponent, subtract it by the exponent of the denominator's base. It's weird.
Sounds weird when you say it. You know, I like the law that you got here. So we know that multiplication and division are inverse operations, meaning that they're opposite. So it stands to logic, if we just compare it to what we're thinking about. We did this one, we multiplied. We did this exponent law using multiplication. And these laws only apply when the base is the same in both of these examples. Here's the division one he's trying to explain now. So if you have the same base and you're multiplying and you have different exponents, you just add the exponents. When you're dividing, being that it's an opposite or an inverse operation, it's the opposite of multiplication. We add it in multiplication, we subtract the exponents in division. So I think that's what we're trying to explain here with this. It's just 5 minus 2. So it's 3 to 5 minus 2, which is equal to
3 to the third, which we saw earlier was 3 times 3 times 3, or
equal to 27.
27. And the last one, let's have a look at the actual form of it, the abstract form. And we have this 3 out here is not being multiplied, it's just number 3. Some number raised to a power, and then this whole quantity is being raised to another power. And we're just going to take that number and we're going to multiply the two exponents. So that could be something as 2 to the 4th, and then this is being raised to the 6th power. Well, this would be 2 to the 4 times 6. That's where we get this m times n. So 2 to the 24th. And this becomes exceedingly helpful when we are dealing with exponents that are rather large. You might not think 24 is a large number, but when you're dealing with exponents, this becomes a large number. Okay,
That's good.
now, the cool thing about this is that these laws can be applied to bizarre exponents, exponents that are fractions. So if we have 2 to the 1/2, and you can have a fractional exponent, and we're going to multiply it like we're doing here. We can multiply this to 2 to the 2/3. Again, remember the bases have to be the same. Then this would be 2 to the 1/2 plus 2/3. And now this goes all the way back to earlier lessons.
And there's videos on fractions, right?
Where we have to deal with fractions. So just remember we need a common denominator. Let's just look at the exponents. We'll write them right here. So we have 1/2, and we'll just put exponents only. I like to label everything, so just in case this is in my own notes, I can go back and say, what am I working with here? So this is plus 2/3. 6 is my common denominator, so I need to multiply this by 2 over 2. I need to multiply this by 3 over 3 and get 3/6 plus 4/6 is equal to 7/6. Therefore, 2 to the 1/2 2 to the 1/2 times 2 to the 2/3 is this, which is equal to, just move this over just a bit, 2 to the 7/6.
Now, just a question, because I have a curiosity here. I want to know, this is improper. Can you make that proper?
Yes.
Or is it just not recommended?
No, it is.
So would it be 2 to the 1?
2 to the 1 and 1/6. But in order to understand what is going on with that answer, we need to look more at what are fractional exponents. What do fractional exponents entail? So, we will make this the investigation of the next lesson.
Do you want to?
Yep.